Hi mathematicians, welcome back to Fact Fluency. At Fact Fluency, we get a chance to explore how we can be flexible, accurate, and efficient when we're working with numbers, especially when we're counting. Being flexible means that I can think in different ways about numbers. Being accurate means I can count correctly. Being efficient means I can do it pretty quickly. Today we're going to talk about an idea called number conservation. That's a really long, fancy way to say how we line up our objects that we're counting can change the way we think about those objects or how many there are. So let's take a look at some examples so you can see. So here you can see some bears on my screen. You even might have some bear counters in your toolkits at school. I want you to look at the row of blue bears and the row of yellow bears. And I want to know, do the rows have the same number of bears? So does my blue row of bears have the same number of bears as my yellow row of bears? Thumbs up if you think yes. Thumbs down if you think no, there's a different number of blue bears than yellow bears. Yeah, I would be giving a thumbs up, but how can we tell? Well, when they're lined up neatly like this, we can see for each blue bear, there's a yellow bear right underneath. There aren't any extras that seem to be sticking out one way or the other. But in order to be sure that we are correct, we can't always just trust our eyes. We have to know that no matter how I line them up, I need to count to see if I'm actually correct or accurate with the number of bears. So let's double check. Here I have 1, 2, 3, 4, 5 blue bears. So let's see if we have 5 yellow. 1, 2, 3, 4, 5. I do. So looking at it, I could see, yeah, I'm pretty sure they have the same number, but counting is a way that mathematicians can be sure, because sometimes the way that those bears are arranged or lined up can be tricky in how we think about it. So let me show you an example of that. Now take a look at my bears. Is the number of bears in each row still the same? It's a little harder to tell, isn't it? Because they're not lined up in the same way. Some of us might look at it and say, no, there are less blue bears. Look, this line of blue bears starts here and stops here. And look at how long the line of yellow bears is. Look, it goes all the way over here and keeps going over here. But wait a minute. As mathematicians, we know we want to be accurate. We want to be careful. And the way that we can do that is to count, to double check. Because I'm noticing that, yeah, they look like they're spread out, which makes the line of bears longer. But look how big the space is in between. So let's count to be sure that they still have the same number. Because some of us might look at this and think there are more yellow ones now. Let's see. There's 1, 2, 3, 4, 5 blue bears still. And there's 1, 2, 3, 4, 5 yellow bears. So the way that they're arranged can sometimes make us think there are more or less than there actually are. So being accurate as a mathematician means we want to count to be sure, because sometimes the way they're arranged can look tricky. Let's see another example. So now I have orange and green bears. Do these rows have the same number of bears? Well, look, it's kind of like our first example. It looks like when I look at each green bear, there's an orange bear right underneath it. But what do I want to do? I want to count to be sure I'm correct or accurate. So let's see, there's 1, 2, 3, 4, 5, 6 green bears. 1, 2, 3, 4, 5, 6 orange bears. So these rows, they looked like they had the same number, and I counted, and they did have the same number. But let's look at the next page. Is the number of bears in each row still the same? What do you think? Should we count again? Give me a thumbs up if you think they still have the same number. Thumbs down if you think, no, there's a different number in each row. Let me see. Well, with an example like this, it's hard to tell because they're not lined out. Some of us might look and say, wow, look, there's less orange bears because look, the line of green bears goes way longer. But the only way to be certain is to count. So let's see. 1, 2, 3, 4, 5, 6 green bears, and 1, 2, 3, 4, 5, 6 orange bears. So counting makes us confident as mathematicians that we know how many bears there are. In this case, it's bears, but no matter what you're using, counting is a way to be sure that we're being accurate, no matter how they're lined up, because sometimes it can trick our minds a little bit into thinking there's more or less than there actually are. So count to be sure, mathematicians. Good work today. When you're working at your rotations, you're going to get a chance to practice this a little bit more for fact fluency. Have fun.